Today we'll be talking about waves in general. In everyday life, people always ask, why when something is closer, why is the pitch louder? But when it's far, the sound pitch is lower. Well, there's something called the Doppler effect. Today we have two specialists who have your answers to your questions. Welcome to the stage, Dwayne Wade.
Hello.
University for 4 years now.
Yes, I'm a professor in the teaching of physics and astronomy department. It's been going really well for me.
Nice. Today we have a question. Why when something is closer, why is it louder? But when it's far, its pitch is lower.
So that's called the Doppler effect. Here's a visual. The Doppler effect was named after Christian Doppler. He discovered the idea of source of sound or wave making, or any wave making source moving toward or away from absorber apparently changes the frequency. So as the source of sound or light comes towards you, which is called the blue shift, its frequency becomes higher. As the source of sound or light goes past you, which is called red shift, its frequency becomes lower. This is how we compute the speed of objects using radar and the expansion of the universe.
Very interesting, Wade. So, an ice cream truck coming towards my house with a loud sound and it passes my house, the frequency of the pitch gets lower. An example of the Doppler effect?
Yes, actually that's a good example.
Well, thanks. You actually gave good explanation and I understand the Doppler effect now.
So is there anything else you want to know about waves?
Well, there's one thing.
Let's go ahead.
What's the difference between longitudinal waves and transversal waves?
Transverse waves are waves that go up and down. Longitudinal waves are waves vibrating in the direction of propagation. For example, transverse waves go up and down. Longitudinal waves are waves vibrating in the direction of propagation.
Thanks for coming on the show. You've been such a big help.
It's my honor to be on your show.
Please give a round of applause for Dwayne Wade. Special guest that came on the show to share some of his knowledge. So give a round of applause for Christian Doppler. Hello. So how's life going?
It's going pretty good.
Wow, that's very impressive. Oh, great energy.
Microwave oven and the heating effect of the sun on the object's surface are two examples of wave carrying energy. Heat energy is transferred from the source of using electromagnetic radiation, microwave, and light waves, but also wave carrying energy by converting the movement into electricity. This can be in the form of kinetic energy and potential energy.
Microwave heat waves are transferred into the mic source, which is popcorn, right? Yes. Okay, I understand. So also another example is sun providing light for plants, right?
Yes. Thermal energy from the sun is transferred by radiation. The movement of energy through space in the form of electromagnetic wave, which is converted into chlorophyll inside a plant.
Well, that's very interesting. I have one last question that I need you to answer.
Sure. What is it?
How do sound waves work?
Well, you see, longitude waves have sound who depends on the speed of the properties of the medium in which it propagates. For example, you can hear me clearly now as we are speaking, but if we go to another room, you won't be able to hear me clearly because of the wall interference.
Oh, I see. So if I were to talk to you through a fan, you won't hear me clearly because of the interference.
Exactly. But if there is But if there was nothing there, I would hear you clearer because there's nothing that's interfering. You can hear me?
No, because sound gets reflected back rather than transmitting through the medium of air. Water is more dense than air, so when talking in the air, it's easier for a speech to be created.
Thank you so much for this knowledge. It's been an honor to have you on my show. Next time for Discovery TV.
Bang bang.